Hello guys, I'll be doing the geometry quiz for you guys for the quizzes for you guys for the periodic. I'm gonna start with 4.4 and I'm gonna go onwards. So basically for this first question you can do the table of values, that nice way of memorizing, but since calculators are allowed, why bother? Sine 30 is actually 1/2, not radical 3/2, so that's wrong. Cosine 30 is radical 3/2, so that's correct. Now you have these special values. What we can do is cosecant is 1/sine. Secant, these have to be memorized. Secant is 1/cosine, and cotan is 1/tan. So yeah, it's basically sine 30. Okay, just do sine 30 and then do the reciprocal of 2, which is 1/2. Is that that? Now secant is gonna be cosine 30. Is it equal to 1/2? And tan 30, is it equal to 1/radical 3? If we rationalize 1/radical 3, we get radical 3/3. We have to rationalize because we cannot have a radical in the denominator. So when we rationalize, we get radical 3/3. Okay, let's do it. Sine 30. Sine 30 is 1/2, so that's correct. Now cosine 30 is radical 3/2 and not 1/2, so this is wrong. And tan 30 is radical 3/3, and that matches up with this. So it's basically this. It's basically the one that's in gray. Okay, we said that sine a number is equal to the cosine of that number, in which the case that these two numbers add up to 90. When we say these two numbers add up to 90, this means that they are complementary. So basically, the sine of a number is equal to the cosine of another number in the case that these two numbers are complementary. This also applies to the cosecant and the secant, since they're the respective inverse of each one of them. It's also gonna be the same. So secant 34, and if it's complementary to 90, we do 90 minus 34, which is gonna be 56. Okay, this one we can visualize it or we can draw it. So we have a triangle A, B, C. It's a right triangle, so B is gonna be right, since B is the middle one, so B is gonna be right. AB is 11, BC is 60, and AC is 61. They want cosine A. We said that sine is opposite over hypotenuse, and cosine is adjacent over the hypotenuse. And we have tan, it's the opposite over the adjacent. They want cosine, so cosine is gonna be the adjacent over the hypotenuse, and the adjacent is 11 and the hypotenuse is 61, and you cannot simplify that, so you put that as the answer. Now we're on to the next quiz. This is just graphing. So if you realize that 4.4 and 4.5 we've had it for the final, so this is just prerequisites. So let's start graphing. Here they want the sine graph. First of all, let's do the sine graph on our own. -1, and here's 1. And here's 180, and here's 360. And here's 0. So it goes 1, like this. Okay, so this is the sine graph. What we have here, but we can notice that, I'll be precise with you, there's 3 unique differences in this graph. Now it's a game. It's not math, but it's a game. It's a puzzle. So can you spot the 3 differences? Let's go. The original equation of this graph is y equals sine x. So let's input the 3 differences. First difference that you can notice, instead of the graph starting up then down, it started down then up. This means that you flipped the graph. That means that the new equation is y is equal to negative 1 sine x, or simply y equals negative sine x. Now this is the new equation. Now we're done with the first difference. Difference number 2. Instead of the graph stopping like you have, like there's 1. No, what's happening here, if you can notice, let me draw this. Okay, I tried my best to draw it, but what you can notice is instead of being at 1, it's at 4. It extended all the way to 4, and that's a clear difference. Okay, so basically you multiplied it by a factor of 4. So yeah, so it became y equals negative 4 sine x. The third difference is more complex. Third difference, we never learned it in class, but we just have to do it ourselves, like just in case it comes in an exam. Usually a sine graph has a period of 360 degrees or 360 units. Okay, here there's also 360 units, and in that 360 units you have only 2 waves. Here's wave 1, let me just draw it in red. Wave 1, it's right here, and then wave 2 is right here. Here there's 4 waves in a 360 graph. That's weird because you only supposed to have 2. So you went from 2 to 4, you multiplied by a factor of 2. Now you're thinking, should I add the 2 in here, like I multiply 4 by 2, or should I add it here? The answer is you should add it on the x, because it's not literally changing the orientation of the graph, it's literally changing the structure of the graph. So if you're changing the structure, you're changing an integral part of the graph, so you're gonna have to change x itself but not sine of x. So the new graph becomes y is equal to negative 4 sine twice of x. So make sure to know that whenever you're changing out the amount of waves, you multiply the number with the variable. But when you're changing the height, the length, not the length. The length is for the x. The height or the orientation, it's gonna be it's gonna be with the sign. Now this next question, you also have to spot 3 differences. Okay, again let's draw a sine graph. Here you have negative 1, and here you have 1, 180, and 360. Let's go 0. It goes 1, then it goes like this. This is the sine graph. You can notice it started at 1. So, but there's a big difference. Usually when we multiply, we see that the peak is at a specific number. This time it started at a specific number. So do we multiply or do we add? The answer is we add, because it started and ends at a number. Not it peaked or it descended at a number. It started and ended. There's a difference between peak and descend and start and end. So you should know. When it peak or descend, you multiply. Start or end, add or subtract. Good? So instead it started from 1, it went up here, and then it, like you know, okay? Yes, it's complicated. Okay, so you added, so the equation was supposedly y equals sine x. It became y equals 1 plus sine x, and positive 1, but just 1. So y equals 1 plus sine x. Another transformation, instead of starting from up then down, here it started down then up. So you multiplied by a negative number. So y equals 1 minus 1 times sine x. So y equals 1 minus sine x. So you inverse it. And that's the second change. The third change is what you have to do. This one you have to visualize very carefully. Peak and descent. If it were to start at 0, if the graph were to start at 0, and in this case we're actually moving backwards, this this last transformation I'm doing now was the first transformation that this graph was applied, like the first transformation that was applied onto this graph. Let's say the graph started at 0. It wouldn't go to 2. If you move it by a degree downwards, it would have gone to -3, and then move up here to 3, and then go down. So you see it goes to 3 here. So that's why you put a 3 here. So we got y is equal to 1 minus sine x, but you add a 3 here because it peaked and descended at 3. Okay, so if you think of it logically, the 3 was the first transformation applied, the negative was the second transformation applied, and the 1 was the last and final transformation to be applied. This one, of course, this quiz is memorization. Memorizing how the graphs of sine, tan, and cosine look like. This is a tan graph. Basically, in a tan graph, there's always an asymptote. So if you can see here, this is the asymptote. We can graph it, but it's just more of memorizing. So numbers never come close to an asymptote. Numbers always go close to an asymptote, but not on it. Okay, so they go so close, but they never touch it. It's impossible to touch an asymptote. Okay, here's the asymptote. I will draw them later in another color. Let me draw them in red. See? That's the asymptote. Okay, what can you notice? There is literally a point touching the asymptote. This point L is touching the asymptote, and that's not possible. No point can ever touch the asymptote. Don't touch the asymptote. Don't protect the asymptote. So L is not a point on the graph. Okay, the graph of 2 sine x. Let's do it. 2, so you go like this. So it touches 2. It touches 2 and -2. It peaks at 2 and descends at -2. So if it were to be y equals sine x, n would be a point and the rest wouldn't be. In this case, it's y equals 2 sine x, so the rest are points on the graph, but n is not. N belongs to the graph y equals sine x. Okay, on to the next section we go. These next two sections, this section and the section that comes after this, are so, even 4.8 is it's the most complicated one, but these next two sections, you think they're easy. AMSs, they came easy. Explanations in class, they came easy. In the quiz, I don't know why, but why are they hard? They're so complex. There's a substitution in the substitution in the substitution. And that's so weird because I've never seen it's so insane because I've never seen there's been a substitution made in a substitution made in another bigger substitution in a trigonometric ratio. Basically, 3 trigonometric identities in a trigonometric ratio made of one trigonometric ratio. It's complicated. So this first question is easy though. So yeah, we're taught that whenever we see a squared one, that's the one we're gonna substitute. So we know that there's this trigonometric identity that we should memorize. So tan squared x plus 1 is equal to secant squared x. So tan squared x plus 1 minus 22 tan x plus 20, and we simplify tan squared x minus 22 tan x plus 21 is equal to 0 here, but let's just delete all of this. Yeah. Let's say a tan x is equal to x. So x squared minus 22x plus 21 is equal to 0. Let's do this. This is the sum, and this is the product. The sum is equal to negative 22 and the product is equal to positive 21. So x minus, they're both negative numbers. it's gonna be 21 and it's gonna be 1. Because negative 21 minus 1 is negative 22, and negative 21 times negative 1 is 21, I mean. So x is equal to 1, and x is equal to 21, and x is equal to 1 is right here, and 21. Yeah, this question is where things start to get complicated. Let's do this. Secant is the reciprocal of cosine. So basically you can do cosine theta is equal to 1 over 2. And we see that the angle is actually 60. I believe so. I memorized it, but yes, it's 60. I'll check it again. Okay, it's theta is equal to 60. We have to see that these 5 options, convert them to degrees and see if their answer is equal to 60, or if we get 1 over 2 out of them. Okay, let's convert these to degrees by doing times 180 over pi. So pi over 3 times 180 over pi, you get 60 here. That's a bargain. That to see the first one is correct, so that's good. 2 pi over 3, you get 120 here, doesn't seem right. And then you get negative 60, and you get negative 240 and 240 here, degrees. Okay, this seems right. You converted them all. Now we successfully converted them all to degrees. Now let's find out if they're equal to 1 over 2. The ones that are equal to 60 are pi over 3 and negative pi over 3. The thing is, one of them gives you a negative answer. But they said, but if you do it in the calculator, cosine 60 is 1 over 2, and cosine negative 60 is also 1 over 2. Do it on the calculator. Do cosine 60, and cosine negative 60. Plug this into the calculator, you will get 1 over 2. So that means that this is the correct answer. So if you're not sure of an answer, recheck. Don't sit there. Just recheck. Tan theta is equal to radical 3 over 3. Let's find theta. Tan theta is equal to radical 3 over 3. Theta is gonna be, we just do the inverse. Tan inverse is equal to radical 3. Tan inverse radical 3 over 3 is equal to 30. Again, we convert all these radians to degrees by multiplying by 180 over pi. So 5 pi over 6 times 180 over pi, you get 150 here, negative 150, and here you get 210, and wait, and here you get 30, negative 30, I mean here you get 30. Now the answer was supposed to be 30, but I'll be honest, you can only see one answer that indicates 30. So if I'm being honest with you, using this way, there is no need to do tan inverse. What you can do is just do tan of each degree and see if it gives you this answer. Let's do tan of 150. Tan 150 gives you negative radical 3 over 3, so this is wrong. Let's do tan negative 150, you get radical 3 over 3. Let's do tan 210, you get radical 3 over 3, so that's correct. Tan 30, tan 30, you get radical 3 over 3, but tan radical 30, 10, oh, what do I mean tan radical 30? 10 negative 30, you get negative radical 3 over 3. So the correct options are these three. So what you just do is you do tan, you take tan and you do negative 150. First of all you get 150 and then you do tan, negative 150, tan, 210, tan, negative 30 and tan 30, and you have to see which ones give you radical 3 over 3. Okay, this one is sine theta radical 3 over 2. Same thing. So sine theta radical 3 over 2. Convert these to degrees. You do times 180 over pi 2 pi over 3 times 180 over pi. You get 120, negative 120. This is most probably gonna be negative 60. Yeah, negative 60, 60, and this one is gonna be 420. Just do sine of each of these. So sine 120, sine 60, sine 420, sine negative 60, sine negative 120. Plug these into the calculator and you have to see which ones of these answers give you radical 3 over 2. This one gives you radical 3 over 2. This one will give you negative radical 3 over 2. This one will give you negative radical 3 over 2. This one will give you radical 3 over 2. This one will give you radical 3 over 2. This is correct, this is correct, these two are not correct, and this is correct. Do the same for cosine. Good thing this time they did not give you the radians, they gave it to you in degrees, so it's just easy. Cosine theta or x is equal to radical 3 over 2. Just do cosine 30, radical 3 over 2. Put them on the calculator. Cosine 60 is 1 over 2, which is wrong. Cosine negative 60 is also 1 over 2, which is wrong. Cosine negative 30 is radical 3 over 2, which is correct. Cosine 330 is radical 3 over 2, and cosine 160 is negative 0.9397, which is wrong. See, these ways are faster. There's no need to do these complex ways. Try it yourself. It will take so much time. Okay, now you substitute what is squared. So sine squared x plus cosine squared x is equal to 1. Just move to the other side. 1 minus sine squared x is equal to cosine squared x. So then 1 minus sine squared x plus 24 sine x minus 24 negative sine, simplified, negative sine squared x plus 24 sine x minus 23, yeah, minus 23 is equal to 0. Just take the negative out, or if, wait, what just happened? Okay, sorry for that. You have negative sine squared x plus 24 sine x, yeah, minus 23 equals to 0. Okay, we got that. Sorry for what just happened. I don't know what happened. We can just take the negative out, or we can just cancel it, or we can, like, if we take the negative out, we have to inverse the whole equation. So the opposite of negative sine squared x is sine squared x. Opposite of 24 sine x is negative 24 sine x. And the opposite of negative 23 is positive 23. So just inverse everything. We can say that sine x is equal to big X. So you turn it into a quadratic equation. So x squared minus 20 minus 24x plus 23 is equal to 0. And then you can say that this is, wait, sum product, and then you can do x minus the sum, which is, so x minus 23 and x minus 1, because if you do negative 23 times negative 1, you get 23, and if you do negative 23 minus 1, you get negative 24, so it's correct. And then you get x is equal to 23 and x is equal to 1. They already mentioned x is equal to 1, so now you put x is equal to 23 in the options, in the answer. Now for this question, tan x is equal to negative 20 over 21. Tan x is equal to negative 20 over 21, and it's obtuse. That means that if we do all students take calculus, we can find that since obtuse, only sign is positive, sign and actually cosecant. So sine and cosecant can only be positive. Everything else is negative. So let's just see if I see any sign that's we can only see sine and cosine, so there's no need to talk about cosecant. Sine must be positive and cosine must be negative. If I see any cosine that's positive, or if I see any sign that's negative, immediately eliminate them. Sine positive, correct. Sine positive, correct. Cosine negative, correct. Cosine positive, immediate elimination. Sine negative, immediate elimination. We can narrow down the answers to be between these three. Okay? So now let's remove the requirement that said obtuse. We eliminated them. خلاص. Now what we can do is do the inverse. Sine inverse of 20 over 29. 20 over 29. It's gonna be 43.6. Okay? Let me just put the full number, 43.6028187. And now sine inverse of 21 over 29 is gonna be 46.3971810. Very long number, but that's fine. Now cosine inverse of negative 21 over 29 is gonna be 136.397181. Now what we can do is we do the tan of these numbers to see if they match up to negative 20 over 21. So it's gonna take a long time. 43.6028187. I get negative 20 over 21. I didn't get a fraction, I got a decimal. So 0.9523809,523. And now let's do tan of 46.3971810. And we get 88.7652933. That's so off. That's like very off. And then we do tan. Wait, no, I did the tan inverse. I did the wrong tan. Sorry. Tan of 46.3971810. You see, please, apologies. The reason you saw me repeating that second part was because I did not do tan, I did tan inverse, which is a very big mistake. So you have to do the normal tan now, and you get 1.05. And then you do tan 136.3971810, and you get negative 0.9523809,533. Now, let's convert this into a decimal. Negative 20 over 21 as decimal is negative 0.952380954. Obviously, this one is the most resembled to it, and this one, but I got a negative answer. This is obviously so off. Now, these two values are obviously the correct answer. We got a negative for the cosine, since cosine must be obtuse, and sine must, since obtuse, cosine must be negative and sine must be positive. So the first and the third ones are correct. So you didn't understand, replay this, and as I told you, any questions, do not hesitate to privately ask me. I'm free, okay? You can ask me. Now this one. Easy. It's easy. We learned that a trigonometric identity sine squared x plus cosine squared x is equal to 1, right? So here we have 0.04 plus sine squared x is equal to 1. Just do 1 minus 0.04, and that's equal to 0.96. Now we can find tan. And tan is sine over cosine. It's actually sine squared x over cosine squared x if it's equal to tan squared x, right? That's true, yeah? So we can do sine squared x is 0.96 over 0.04. Let's do that. 0.96 divided by 0.04, and that's equal to 24. So that's true. Now on to the next quiz. Okay, so we have a triangle RST. Measure of angle R is 30, measure of angle T is 60, and then this is gonna be right. It does not look like a right triangle, so let's just redraw it. R, S, T, 30, 60. Okay. Yeah. And ST is 10 radical 3, and then this is gonna be X. A over sine, use the sine rule. A over sine A is equal to B over sine B. Let's say A is equal to X, which is RS. So A is equal to X is equal to RS. Okay. Sine A, so basically the opposite side. So sine 60 is equal to B, which is 10 radical 3. And the opposite angle of 10 radical 3 is sine 30. You cross multiply, you do all that, and you find that X is equal to 30. And that is equal to RS. For this triangle, you can also use the sine rule. So you have A over sine A is equal to B over sine B. A is, let's say this is A and this is B. A is 14 radical 2, and then the opposite side is going to be sine 45, and B is going to be 24. And the opposite is going to be sine x. So you do 14 radical 2, 14 radical 2. Oh, sorry, you could do 24 times sine 45 over 14 radical 2. This is going to give you what? It's going to give you sine of x. Okay, the sine of x is equal to that. But you don't want sine of x, you just want x. So what you do is you were supposed to do this, the inverse of this. So you do sine inverse of this fraction. But there's a plot twist. They don't want x, they want sine of x. Look here, they said sine of x. If they just said x, then you do sine inverse. But since they said sine of x, you do not do sine inverse. So just put this. Don't do sine inverse, only do sine inverse if they ask you for x. But since they ask you sine of x, here sine of x, you just put this in your calculator. You will get 6 over 7. They only want the denominator, so you put 7. Take note of that. Let's draw this. We have triangle ABC, A, B, C. BC is gonna be 6. AC is gonna be 11. Angle C is gonna be equal to 60. They want the square of AB. Okay, we have two sides. We want to find the measure of the length of one side, and we have one angle. Perfect rule that seems for this is the cosine rule. The cosine rule, let's just give x to be a, or yeah. So x squared is equal to, let's just say that this is a and this is b. A squared plus b squared minus 2ab plus cosine c. Also, let's just name this c. Yeah, so what is a squared? So 11 squared is gonna be 121, and b squared is gonna be 36, and then minus 2 times 11 times 6 minus 2 times 11 times 6 plus cosine, actually times, no, not plus, times cosine 60, and you put that in the calculator and you get c squared is equal to, or ab squared is equal to 91. And they didn't want just ab, they wanted ab squared, so there's no need to square root 91. Okay, seems like we're gonna have to apply the sine rule. C is equal to 40 sine c, so this is gonna be 0.5. So if sine c is equal to 0.5, sine inverse of 0.5, so sine inverse 1 over 2, or 0.5, is gonna be equal to 30. So this angle is equal to 30, and sine b is gonna be equal to 0.8. So sine inverse 0.8 is about 53 degrees. Okay, so just do a over sine a is equal to b over sine b. So a, actually we're gonna be working with b and c. So b is what we need to find. Sine b is 53. Let's just use their values, 0.8, and sine c is sine 30, which is given, so 0.5, and c is 40. So you cross multiply, you do 40 times 0.8, and you divide that number by 0.5 when you cross multiply, and you will get 64. Now you do the same for this one. Seems like we'll be using the sine rule. So yeah, you need to find AB. Let's label it as C, because it's opposite of C. We have to label it as C, actually. There's no option. So B is 36 over sine 37, and here they gave us an approximation, which is 0.6, what we have to use. So 36 over 0.6 is equal to C over sine 30, which is 0.5, and you do 36 times 0.5, and you divide that by 0.6, and you will get 30. You just cross multiply. Okay, looks like we have to use the cosine rule. So cosine rule is a squared is equal to b squared plus c squared minus 2bc plus times, cosine a. This time they want cosine a, so you have to isolate it. How do we do it? A squared minus b squared minus c squared divided by negative 2bc is equal to cosine a. That's another variation of the cosine rule. Let's plug these values in. A squared is 15. You see, it's literally the opposite. So c squared is 18 and b squared is 9. So minus 9 squared minus 18 squared divided by negative 2 times 9 times 18. You plug this into the calculator, and you'll get cosine a, not a, cosine a, to be 5 over 9. Now, did they say they wanted A or did they say they wanted cosine A? They wanted cosine A. So you just put 5 over 9. They just wanted the numerator, so you put 5. If they wanted cosine A, you do cosine inverse of 5 over 9 and then you find A. But this time they wanted cosine A, so no need to overcomplicate it. They want the area of a triangle. There's a specific rule to find the area of a triangle using the sine rule. And let me just open the screen right now for you. Okay, so that way is the area is equal to half of AB sine C. Okay, half of A, so half of AB, but this time they give you the angle B, so you have to, it's half of AC times AC sine B, so half of 20 times 22 times sine 37. Put that on the calculator and you'll get a very big decimal, 132.3993051. Round it up, you get 132, and that's the area to find it with the using sine. Okay, seems like we're gonna have to use the sine rule again. C is 52. Sine C is gonna be 0. Okay, let's just do it. B over sine B is equal to C over sine C. B is what we need to find. Sine B is 0.4, they gave it to you. Sine C is 0.8 and C is 52. Cross multiply, plug it in the calculator, you'll get B is equal to 26. Okay, seems like we're gonna have to use the sine rule again. It's just simple applications of the sine rule. So y over sine y is equal to x over sine x. Yeah. Okay. So let's find y is, actually it's not given. Oh, you need to find y. And sine y is gonna be sine 35. And you didn't get the side z, but you did get the angle of z. But you need to use the side of x. What do you do is 35 plus 115. So you do 35 plus 115 plus x is equal to 180. Okay? And you find that x is equal to 30. So, okay, you understood why? Because they gave you the side of x, but not the angle. But they give you the angle of z, but not the side of z. So it's easier to find the angle of x because it's impossible. You cannot find the side of xy. So then you get is equal to 30, and then you do sine 30, and x is 200, and you cross multiply, plug it in the calculator, and you'll get y is equal to 228. But actually you'll get like 129. But that's why they're telling you that you have to use that sine 35 is 0.57. So they want you to use their value, and then if you cross multiply, then you'll get 228, not 229. So you should be really careful. If they specify you, then you should use that one. Good luck, guys. 4.8 will be made by Ali. Sorry for the long explanation, and I hope you understood. If there's one question that you didn't understand because of my poor explanation, please make sure to reach out for me. If you want to give me feedback, please privately message me to tell me the ups and downs, and thank you so much. Good luck.